So the purpose of this video is to show you how to do 2013 section A, question A1. The 3D graphics below shows the Rubik's Cube and display stand. The drawing on the right shows the incomplete projections of the objects. Part A, complete the elevation. So we've got a plan and end elevation. Alright, so to start off, okay, project all your lines from plan straight up, okay, and all your lines from end elevation straight across. So we can do that now. So them all brought straight up from plan. Now I bring all the points from end elevation straight across. Okay, so then done. Now it's about figuring out which ones are which. So I'd use this what you call a 3D graphic to help me is that bottom, that face there that I hover or hashed in blue is this bottom face here. So I'm going to call this A, D. So when you're looking in there from the left, you project it on the right, so this is the end elevation, so B, C, D. And then I'm going to give these numbers 1, 2, 3 and 4. So this is 1, 2, 3 and 4. So in where they in plan view is the question. So we can drop these points down to our 45-degree line, and we can bring them across to help locate them in plan view, so we can have an idea as to where they're going to be in elevation. Right, 1 and D will be exactly in line. As I said, yeah. No. So this will help us figure out where they are. Right, so this is point A, this is what you call it B, C, this is D, and then number 1 down over, so that's 1/D, then 2 and 3 is here, and number 4 is there. So if we want to figure them out in elevation, we're going to bring a 1 up until it hits 1. Improve the focus of the visualizer. So we're going to bring 1 straight up until it hits 1 going across. There's number 1. 2 up until it hits number 2 going across. Same with 3. Okay, same with B and C. B and C across until it hits B and C. And number 4. And then D, what you call it? That's number 4. I've got to do A across and A up, and then D. Now, so the letters are going to join together, the numbers are going to join together, and then numbers will join to the letters. A joins to B, so I can heavy A to B together. I'm going to see that line, so that's going to be hidden. B joins to D. I'm only going to see a portion of that line. There'll be some hidden detail. D joins to C, which is here, so a portion of that will be hidden detail. Okay, C joins to A. Now, 1 joins to 3 and 1 joins to 2. So I'm going to join 1 to 2, 1 to 3, and now 1 joins to A, I'm going to join 1 to A, 3 joins to C, so I'm going to join 3 to C, 2 joins to B, and I have a lot of it done now, but 2 joins to 4 and 4 joins to 3. That's inside the cube, so that's hidden detail. And the next part of the question is determine the diameter of the smallest possible sphere, smallest possible, that will contain the cube, and draw the sphere in the end view. Alright, now you have to find something called the long diagonal. Now the long diagonal is a line that joins one vertex to a vertex here on the opposite side. So look, that's an example. This is an example of something that is not a long diagonal. See, it joins a vertex on the same, 2 vertices on the same face, so that's not a long diagonal. This point here, if I join that point to this finger here, that's a long diagonal. Now 1D is a long diagonal and it appears as a point in plan, so that means 1D is a true length in end elevation and elevation. Okay, it's a true length. Okay, so if you're going to draw the sphere, you have to see the long diagonal as a true length. Okay, and here we have it there. Now you can bisect that long diagonal, so I'll just get my compass. So you can bisect that there. Join them together, and now you put your compass on your center point, bring it to the points outside, and there's a little bit of accuracy wise compass slip there. There it is there. So there's the sphere in the end view. It just says draw the sphere in the end view. If you want to put it into the other ones, center point remains the same, radius remains the same. Okay, it doesn't have to touch all the points in the different views. So there's the plan view of it. The elevation, it's just directly across. Again, radius remains the same. And there you go. Cheers, thank you, bye bye.